Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out the practice questions from the Mathematics Knowledge Subtest of the 9th full-length practice test on my website. If this is your first time finding my YouTube channel, I want to mention this. I have a small website called ASVABapp.com. There you can take 9 full-length practice tests, including this one. If for some reason you don't want to use my website to take this practice test, you're more than welcome to work out the problems alongside me here on YouTube. In that case, I'd recommend that you pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a reference sheet or a calculator on the ASVAB, so regardless of where you work out these problems, make sure not to use any of those resources. So all that being said, let's go ahead and get started with today's video. All right, so this first question says evaluate the expression using the given values. We have 2x to the third minus x squared plus y to the third for x equals 3 and y equals negative 2. So to start, I'm simply going to copy down the expression that was given. Again, that was 2x to the third minus x squared plus y to the third. And I'm also going to note that we were told to let x equal 3 and y equal negative 2. The first thing we want to do in this case is substitute 3 in wherever we see x in our expression and negative 2 in wherever we see y. So let's go ahead and do that. This becomes 2 times 3 to the third minus 3 squared plus negative 2 to the third. All right, so at this point, it might be helpful to write down the order of operations to decide what step you're going to do next. Again, I remember the order of operations by the acronym PEMDAS, or please excuse my dear Aunt Sally. This tells you the order in which to evaluate expressions. You do what's in parentheses first, if there are any, exponents next, multiplication and division as they appear in the expression from left to right, and then finally addition and subtraction as they appear in the expression from left to right. Well, if we look through our expression here, you can see we have no parentheses, so there's nothing to work out there. That said, we have some exponents. We have 3 to the third, 3 squared, and negative 2 to the third. So before we do anything else, we have to go ahead and take care of those exponents. And I'm going to work them off to the side so it's very clear as to what I'm doing. Again, we have 3 to the third. We have 3 squared. And we also have negative 2 to the third. All right, so let's take these one by one. 3 to the third is the same as 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So 3 to the third is 27. 3 squared, that's the same as 3 times 3. 3 times 3 is simply 9. What about negative 2 to the third? Well, that's the same as negative 2 times negative 2 times negative 2. All right, and let's work this out step by step so we don't make any mistakes. Negative 2 times negative 2. We have a negative times a negative. So this is going to become negative 2 times negative 2, it's going to be positive 4. Positive 4 times negative 2 is going to be negative 8. Again, a positive times a negative is a negative. One way you can remember this is like this. If you have a negative raised to an odd power, your result's going to be negative. If you have a negative raised to an even power, your result's going to be positive. All right, otherwise you can just work it out like I just did there. So now that we know those values, let's go ahead and plug them in. This becomes 2. We said 3 to the third was 27 minus 3 squared we said was 9. And then we said negative 2 to the third was negative 8. All right, so we took care of our exponents. And let's see what else we have left. We have multiplication right here, 2 times 27, and then subtraction and subtraction. So clearly we're going to do our multiplication before we take care of our subtraction. And in case you can't do that mentally, let's do it off to the side. We have 2 times 27. 7 times 2 is 14, carry a 1. 2 times 2 is 4 plus 1 is 5. So this is 54 minus 9 minus 8. We could do this as 54 minus 9 and then subtract 8 from that, but we can actually go ahead and combine 9 and 8. 9 and 8 is 17. So this is 54 minus 17. And let's go ahead and take care of that. Now I'm going to work it off to the side in case we can't do it mentally. 4 minus 7 we can't do, so we're going to have to borrow. This is going to become 4. This will become 14. 14 minus 7 is 7. 4 minus 1 is 3. 54 minus 17 is 37. So the answer to this one is C, 37. This is a fairly common question that shows up on the ASVAB insofar as it tests your knowledge of the order of operations. In addition, it tests your ability to multiply negative integers by each other. So be prepared to work out questions like this, especially in the beginning of the test. Again, they're very common. All right, this next question says, what are the factors of 2x to the third minus 10x squared plus 3x minus 15? All right, so not surprisingly, I'm going to start this one by copying down this expression. Again, on the ASVAB, you are going to have scratch paper, and I strongly encourage you to use it. So we have 2x to the third minus 10x squared plus 3x minus 15. And we're being asked to factor this expression. Well, we should realize that we can actually factor this expression pretty quickly by using a technique called factoring by grouping. And what that technique says to do is, imagine that you split this expression in half. So if it's helpful, we can draw some dotted lines here to indicate that we're splitting this expression in half. And if I look at just these first two terms, 2x to the third minus 10x squared, it should be obvious that I can factor out a 2x squared. And when I do that, that leaves me with x minus 5 over here. And what about from this second pair of terms? Again, we want to factor something out such that we get x minus 5 in parentheses. Well, what if I factor out a 3? That leaves me with x minus 5 in parentheses. And now, according to the technique, all we do is copy down one of the repeated terms. So x minus 5 is going to be one of our answers. And then we combine these two, notably 2x squared plus 3 as our other answer. And just like that, we factored this via grouping. And as we can see, that is answer choice A. All right, and let's just confirm that. Yep. So on my YouTube channel, I have about 4 or 5 videos in reference to all the factoring techniques you need to know for the ASVAB. Factoring can be difficult because you have to be able to look at an expression and decide which of those techniques to use to factor it. So again, make sure you know how to factor for the ASVAB. Some of the factoring questions will be very easy, and some of them will require you to use some critical thinking to figure them out. All right, so that's this one. All right, so number 3 says, what is the area of a parallelogram? Area equals base times height. It has a base of 3x minus 7 and a height of 5x plus 6. All right, so in this case, we're given the formula we need to use. Area equals base times height. And in addition, we're told what the base and height of this parallelogram is. According to the problem, our parallelogram has a base of 3x minus 7 and a height of 5x plus 6. So let's just go ahead and plug those things in accordingly. This becomes 3x minus 7 times 5x plus 6. So that is the area of this parallelogram. Unfortunately, if we look through our answer choices, we can see that that is not there. And in light of that, that should be a clue that we're going to have to expand this via the distributive property. That is, we're going to take this 3x and we're going to multiply it here as well as here. Then we're going to take this negative 7 and multiply it here and here. All right, so let's go ahead and do that. 3x times 5x is 15x squared. 3x times 6x is going to be plus 18x. Negative 7 times 5x is negative 35x. And then negative 7 times 6 is going to be negative 42. All right, so at this point, we should be able to identify our answer. It's going to be B. That said, if we want to work this out fully, we have to combine like terms, notably 18x and negative 35x. So let's go ahead and do that. We can actually regard this like this. 35 minus 18, but we know our answer is going to be negative since negative 35 is bigger than positive 18. 5 minus 8 we can't do, so we have to borrow. This becomes 2. This becomes 15. 15 minus 8 is going to be 7, and 2 minus 1 is 1. So this becomes minus 17x minus 42. All right, and we can see that is in fact answer choice B. All right, so again, you have to be able to multiply polynomials for the ASVAB. That topic is frequently tested on it, so make sure you can do that. All right, so number 4 says subtract 5x squared minus 8x plus 6 from the sum of 3x squared minus 4x plus 2 and 7 minus 5x squared minus 6x. So the first thing I have to do is sum these two polynomials. I have to sum 3x squared minus 4x plus 2 and 7 minus 5x squared minus 6x. So let's go ahead and do that. Again, we have 3x squared minus 4x plus 2. And we're going to add to that plus 7 minus 5x squared minus 6x. All right, so when you add polynomials together, the only thing you really have to do is combine like terms. And what are like terms? Like terms have the same letter variables raised to the same powers. So in 3x squared, for example, we have the letter variable x raised to the second power. If we look through this expression, we should see that its like term is right here. We have x raised to the second power. So let's combine these two. 3x squared minus 5x squared is negative 2x squared. And once you combine them, you typically want to cross them out. Right now we have negative 4x and negative 6x. Those are like terms. Negative 4x minus 6x is negative 10x. Cross those out. Then we have 2 plus 7, which is going to be 9. All right, so now this is where things get a little tricky. We want to subtract 5x squared minus 8x plus 6 from this. So what you actually have to do is you have to put a subtraction sign and parentheses because we're subtracting all of these terms from this polynomial. So this becomes minus 5x squared minus 8x plus 6. All right. Now that we've set it up correctly, we have to take this negative and distribute it here, here, and here. So let's go ahead and do that. This becomes negative 2x squared minus 10x plus 9. Negative times positive 5x squared is negative 5x squared. Negative times negative 8x is going to be plus 8x. Again, a negative times a negative is a positive. And a negative times positive 6 is negative 6. All right, so let's go ahead and start combining like terms again. Again, we have negative 2x squared and negative 5x squared. Those are like terms. Negative 2x squared minus 5x squared is negative 7x squared. Let's cross those out now. Then we have negative 10x and positive 8x, which is just going to be negative 2x when we combine them. Then we have plus 9 minus 6, which we should know is positive 3. All right, so our answer to this one is negative 7x squared minus 2x plus 3. And that is letter choice B. Again, on my YouTube channel, I have 2 videos in regard to polynomials. The first one is adding and subtracting polynomials, and the second one is multiplying polynomials. This question tested your ability to add polynomials as well as subtract polynomials. So make sure you can do that for the ASVAB. All right, number 5 says, if C is -10, then what is F? Use C equals 5 over 9 times F minus 32. In case it's not obvious, C stands for Celsius and F stands for Fahrenheit. So in essence, we're converting Celsius to Fahrenheit. If you watched my video on that, you'd realize that I said you don't need to memorize this formula. More than likely, it's going to be given to you on the ASVAB. That said, you have to be able to do the math in order to make the conversion. So that's what we're going to do here. Again, I'm going to start, not surprisingly, by copying down the formula. And that formula is C equals 5 over 9 times F minus 32. We know what C is. According to the problem, C is -10, so we'll go ahead and plug that in just a minute. And we want to know what F is equal to. So ultimately, we're going to be solving this equation for F, such that we get F equal to something by itself. All right, so let's substitute -10 in for C. This becomes -10 equals. Now, I'm going to leave a big space here because I know I have to deal with this fraction here. So this becomes -10 equals 5 over 9 times F minus 32. Now, the next step is to get rid of this fraction. And one way we can do that is by multiplying both sides by its reciprocal. The reciprocal of 5 over 9 is 9 over 5. And you'll see that when we multiply 5 over 9 by its reciprocal, this crosses out here and this crosses out here, leaving you with F minus 32 on this side. And believe it or not, 9 over 5 times -10 is actually very easy to do. Again, we can write -10 as a fraction by placing it over 1. And now we can say this. 5 goes into 5 one time. 5 goes into 10 two times. So this is -2. So what we have here is 9 over 1 times -2 over 1. And let me write that off to the side. We have 9 over 1 times -2 over 1. Well, 9 over 1 is the same thing as 9. Again, 9 divided by 1 is just 9. And -2 over 1 is the same thing as -2. So this becomes 9 times -2, or -18. All right, so let's go ahead and solve for F now. The only thing we have to do is add 32 to both sides now. This crosses out here, leaving you with just F on this side. And now we have -18 plus 32. That's the same thing as this, 32 minus 18. And let's go ahead and work it out in case we can't do it mentally. We have 2 minus 8, which we can't do. Let's borrow. This becomes 2. This becomes 12. 12 minus 8, that's 8, 9, 10, 11, 12. That's going to be 4. And 2 minus 1 is just 1. In math, it's customary to write the variable for which you solved on the left. So this becomes F equals 14. All right, so the answer to this one is A, F equals 14. And I do have a video on making these conversions. So if you need more work with dealing with these fractions, check out that video. I think I do 4 examples in that video. And if you watch it from start to finish, you should be able to get these questions right on the ASVAB. All right, number 6 says, write the equation of a line that is parallel to y equals x plus 3 and passes through the point -4, 1. Well, for this one, we have to know one simple fact about parallel lines. Parallel lines have the same slopes. So in other words, the equation of our line is going to have the same slope as y equals x plus 3. So let's go ahead and identify the slope of y equals x plus 3. Again, this is written in slope-intercept form, so it looks like this. Y equals mx plus b, where m is the slope of the line. And this one's a little tricky. Normally there's a value in front of x, but whenever there's no value in front of x, it's always implied that there's a 1. So the slope of this y equals x plus 3 is actually 1, and we know that's going to be the same slope of our line. All right, so how can we use this point, notably -4, 1, and the slope of our line to write an equation for our line? Well, we can actually plug these values into the point slope equation, which is y minus y1 equals m times x minus x1, where x1 and y1 are simply values of your point. So this would be x1 and this would be y1. We already know m is our slope, and we know that's going to be 1. So let's go ahead and plug those things in and simplify accordingly. This becomes y minus, what is y1? It's right here. It's 1 equals m. What is m? It's 1 times x. What is x1? It's -4. Well, this double negative here simply becomes positive. So minus -4 simply becomes plus 4. So this becomes y minus 1 equals, let's go ahead and take this 1 and distribute it here and here. 1 times x is just x. 1 times 4 is just 4. And now let's add 1 to both sides to get y by itself. This crosses out here, leaving you with y equals x plus 4 plus 1 is 5. So the equation of our line is y equals x plus 5, which we can see is C. All right, you could have solved this one much quicker. Again, if you knew that parallel lines have the same slope, you'd have known that the slope of this line is 1. And if you look through all of our answer choices, you can see the slope here is -1, so that's not correct. The slope here is -1, so that's not correct. And the slope here is -5, so that's not correct. So again, there's multiple ways to do these problems. In this case, you could have done it the long way, which I encourage you to know how to do. But at the same time, you could have also said, well, parallel lines have the same slopes. If I look through all my answer choices, only one of them has the same slope of this line that was given. Therefore, it has to be the correct answer. All right, so that's that one. All right, so number 7 says, which of the following is a prime number? We have 72, 63, 123, and 193. Just to recap, we say a number is prime if it's only divisible by 1 in itself. So for example, we would say the number 5 is prime because it only has 2 factors, notably 1 and 5, which is itself. Well, how are we going to determine which of these numbers is prime without doing a lot of work here? Well, let me go ahead and show you. We have 72, 63, 123, and 193. We can actually apply divisibility rules to check to see if these numbers are divisible by 2, 3, 4, or 5 very quickly and in our head. And if any of these numbers is divisible by 2, 3, 4, or 5, then they are not prime. All right. And I'm not going to do all these because I have a video on how to use the divisibility checks for 2, 3, 4, and 5. Instead, I'm just going to focus on 3 because looking at these set of numbers, I already know which one's prime. Well, how do you use the divisibility check for 3? The divisibility check for 3 says if the sum of the digits in a number is divisible by 3, then the number itself is divisible by 3. So for 72, we want to sum its digits. So 7 plus 2. 7 plus 2 is 9. Is 9 divisible by 3? It is. Since the sum of the digits in 72 is divisible by 3, I also know 72 is going to be divisible by 3. Again, let's sum the digits in 63. That's going to be 6 plus 3. 6 plus 3 is 9. Is 9 divisible by 3? It is. Therefore, I know 63 is also divisible by 3. What about the sum of the digits in 123? That's 1 plus 2 plus 3. 2 plus 3 is 5 plus 1 is 6. Is 6 divisible by 3? It is. Therefore, I know 123 is also divisible by 3. And since 72, 63, and 123 are all divisible by 3, that is something other than 1 in themselves, they're not prime. And by process of elimination, I know 193 has to be prime. And we can do a divisibility check for 3 if we want. 1 plus 9 plus 3 is 10 plus 3, which is 13. Is 13 divisible by 3? It's not. Therefore, 193 is not divisible by 3. All right, so to answer these questions on the ASVAB, you have to understand divisibility rules as well as the definition of prime numbers. I have a video on that if you need to review it. And again, I recommend you run divisibility checks for 2, 3, 4, and 5. All right, so that's that one. All right, so number 8 says, what is the product of the reciprocals of 3 over 4, 1 over 8, and 12? All right, so first things first, we have to figure out what the reciprocals of each of these numbers is. So that's going to be 3 over 4. We got to figure out what its reciprocal is. 1 over 8, we got to determine what its reciprocal is. And 12, we'll have to determine what its reciprocal is. Well, reciprocal just means flip-flop your numerator and denominator. So our 4 is going to become our numerator, and our 3 is going to become our denominator. So the reciprocal of 3 over 4 is 4 over 3. We're going to do the same thing here. We're just going to exchange our numerator and denominator. So the reciprocal of 1 over 8 is going to be 8 over 1. And this one's a little bit more tricky. We have 12. Well, we can write 12 as a fraction by placing it over 1. And now all we have to do is exchange our numerator and denominator. So the reciprocal of 12 over 1 is 1 over 12. All right, so now that we found all of our reciprocals, we want to find the product of them. So we're just going to multiply them all together. This becomes 4 over 3 times 8 over 1 times 1 over 12. And when you multiply fractions like this, you simply multiply straight across. So this will become 4 times 8 times 1 over 3 times 1 times 12. And that's actually pretty easy to do. 4 times 8 is 32. 32 times 1 is just 32. So this becomes 32 over 3 times 1 is just 3. 3 times 12 is going to be 36. Unfortunately, that's not one of our answer choices because we can actually simplify this. More specifically, we can divide 32 and 36 by a common factor of 2. 32 divided by 2 is going to be 16. And 36 divided by 2 is actually going to be 18. And we can reduce this one more time by dividing 16 and 18 by 2. 16 divided by 2 is 8. 18 divided by 2 is 9. So the product of these reciprocals is actually 32 over 36, which we simplify to be 8/9, which is answer choice A in this case. All right, so that's that one. All right, so number 9 says, if 5 to the x equals 625, then what does x equal? So we have 5 to the x equaling 625. Well, let's think about it this way. If x was 2, this would say 5 squared, which is the same as 5 times 5, and we should know 5 times 5 is 25. If x was 3, this would be 5 to the third, which is the same as 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. If x was 4, this would be the same as 5 times 5 times 5 times 5. 5 times 5 is 25, times 5 is 125, times 5 is 625. So in this case, it should be obvious that x in this case is going to be 4. In other words, 5 to the 4th power is in fact 625. All right, so that's that one. All right, so number 10 here says, what is the length of the diagonal of a rectangle that has a length of 6 and a height of 5? All right, so we know we're dealing with a rectangle, so let's draw one of those very quickly. And we should know that In rectangles, this side's equal to this side, and this side's also equal to this side. According to the problem, our rectangle has a length of 6, so that's 6, and that means that's also 6. Likewise, we know it has a height of 5, so that's 5, and that's also 5. We want to know the length of the diagonal of this rectangle, so we want to know the distance from there to there. Well, it may not be obvious, but when you draw a diagonal on a rectangle, you actually create two right triangles. And I'll go ahead and pull one of them out for you so it's a little more obvious. All right, there's one of our right triangles. Now, here's where some critical thinking comes into play. Our hypotenuse here is the same length as the length of this diagonal. So in other words, if I figure out what this hypotenuse is, I'll know the length of our diagonal of our rectangle. Well, how do we find the hypotenuse of a right triangle? We use the Pythagorean theorem, which says a squared plus b squared is equal to c squared, where a and b refer to the legs of the right triangle, and c refers to the hypotenuse of the right triangle. The hypotenuse is always directly across from the right angle, so this is c, and in light of that, we can let a be 6 and b be 5. So let's go ahead and plug those in. This becomes 6 squared plus 5 squared equals c squared. 6 squared is 36. 5 squared is 25 equals c squared. Let's add these together, and if you can't do that in your head, we can do it off to the side. We have 36 and 25. 6 plus 5 is 11. Carry a 1. 3 plus 1 is 4. Plus 2 is 6. So this becomes 61 equals c squared. Again, we just want c, so we're going to have to take the square root of both sides now. This crosses out here, leaving you with just c, and we can see that c is equal to the square root of 61. In math, it's customary to write the variable for which you solved on the left, so this is c equals the square root of 61. All right, so we know our hypotenuse is the square root of 61, which means that the length of the diagonal of our rectangle is also the square root of 61, which we can see as b in this case. All right, so that's that one. All right, number 11 says, if you deposit $4,000 into an account that earns 10% in annual interest and is compounded annually, how much money will be in the account after 1 year? Use A equals P times 1 plus R over N to the NT power. A is the amount in the account. P is the principal, that is the amount you invest. R is your interest rate in decimal form. N is the number of times interest is compounded per year. And T is the time of your investment in years. All right, so it should be obvious that we're going to be plugging things into this formula to find compound interest. If you've watched my video on compound interest, you know that you do not have to memorize this formula for the ASVAB. If you see a question involving compound interest, this formula more than likely is going to be given to you. So again, that's A equals P times 1 plus R over N to the NT power. All right, P is the amount you invest. And right here, we know we invested $4,000. So P in this case is 4,000. R is your interest rate in decimal form. We're told that the account earns 10% interest. So that's going to be 0.1. So we know R is 0.1 and is compounded annually. If something's compounded annually, that means it's compounded once per year. So N in this case is just 1. How much money will be in the account after 1 year? Well, T refers to time, and that's time in years. We're only investing for 1 year, so T in this case is also 1. All right, so with those things identified, let's go ahead and plug them in accordingly. This becomes A equals principal, which we know is 4,000 times 1 plus our interest rate was 10% in decimal form, that's 0.1 over N, which is how many times interest is compounded per year. We know that's 1. Again, N is 1, and we're only investing for 1 year. So this is 1 times 1. All right, so let's go ahead and work this out. This is actually very easy. Again, if you have a question involving compound interest on the ASVAB, the numbers are going to be very easy to work with. They just want to see if you can plug in the numbers in the right place and do the basic math to reduce the equation. So this becomes 4,000, and let's work this out in parentheses. This is 1 plus 0.1 over 1. Anything divided by 1 is just itself. So this becomes 1 plus 0.1 divided by 1 is just 0.1. And then 1 times 1 is just 1. Anything raised to the first power is just itself. So let's go ahead and keep simplifying this. This becomes 4,000. 1 plus 0.1 is 1.1. Again, that's raised to the first power. So that's just going to be 1.1. So this becomes 4,000 times 1.1. And once we work that out, we'll go ahead and know what our answer is. Again, anything raised to the first power is just itself. So all we have to do is 4,000 times 1.1. In this case, we're multiplying a whole number, notably 4,000, by a decimal, notably 1.1. To make this a little bit easier, what we want to do is shift this decimal in 1.1 one time to the right, such that this becomes 4,000 times 11. And once we work that out, we'll take our one decimal that we shifted to the right here and shift it back into the left. All right, so let's go ahead and work on that. 1 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. 1 times 4 is 4. Before we start multiplication with this second one, we have to bring in 1 0 placeholder. 1 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. And 1 times 4 is 4. Let's add these together now. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 0 is 4, and 4 plus nothing is 4. Bring in our one decimal, and we can see that 4,000 times 1.1 is 4,400, which is our answer, and we can see that that is in fact answer choice A. All right, so that's that one. Again, if you see a problem involving compound interest on the ASVAB, the math's going to be very easy to work out. But that said, the most challenging part is identifying things and plugging them into the formula. Again, if you look on my channel, you'll see that I have a video in regard to working out problems involving compound interest. Please check it out if you didn't understand what I did in this problem. I think I work out 5 or 6 examples in that video. So make sure you can do problems like this for the ASVAB. All right, number 12 says, what is the height of a triangle that has a base of 15 and an area of 300 square feet? All right, so for this one, it should be obvious that we're dealing with finding the area of a triangle. And to do that, we would use this formula. Area equals 1/2 base times height. And we're actually given a few of these things. According to the problem, we know our triangle has a base, our B, of 15, and an area, or A, of 300. And we want to know its height. So all we have to do is plug in 15 for B, 300 for A, and then solve for H. So let's go ahead and work on doing that. This becomes 300 equals 1/2, our base is 15, times height. Now, a lot of people would get stuck right here because they would do 1/2 times 15, which would be 7.5. Well, that's actually the wrong way to approach this one. Let's clear this fraction of 1/2 from this side of the equation by multiplying it by its reciprocal, notably by 2 over 1. And we have to do that to both sides of the equation. This crosses out here and here, and this just leaves you with 15 times h on this side. And this is actually very easy to do. Again, 2 over 1 is the same thing as 2. So this is really just 2 times 300, which is 600. Okay, so now we're just solving for h. So let's divide both sides by 15. This crosses out here, leaving you with just h there. And now we can actually do some very simple mental math to figure this out. Well, I'm going to treat this like this. What is 60 divided by 15? Well, that's 15, 30, 45, 60. So that's going to be 4, and then just tack on that 0. So 600 divided by 15 is going to be 40. So we know h in this case is 40. In other words, the height of our triangle is going to be 40 feet. All right, so that's this one. Again, you got to be good with multiplying by reciprocals, as well as clever in how you apply mental math to work out these problems efficiently. So normally, these questions are very easy in my practice test, but occasionally I'll throw one in there to see how good you are with mental math. All right, so that's this one. All right, so number 13 says, if the radius of one circle is 6 inches and the radius of a smaller circle is 4 inches, how much more area does the larger circle cover than the smaller one? Use 3.14 for pi. All right, so this one should be pretty simple. We're simply going to take the area of the big circle, and we're going to subtract that by the area of the smaller circle. And in this case, we're dealing with two circles. So we know to find the area of a circle, it's going to be pi r squared. So this is going to be pi r squared minus pi r squared. Of course, this r refers to the radius, and we know this is going to be the radius of the big circle, which is going to be 6. And this radius is going to be the radius of the smaller circle, which is right here. It's 4. So let's plug this in. It becomes pi 6 squared minus pi 4 squared. All right. 6 squared is 36. So this is 36 pi minus 4 squared is 16. Again, 4 squared is the same as 4 times 4. So this is 16 pi. You do not want to plug in 3.14 for pi at this point because it would create a lot of work to do. Instead, what you want to do is 36 pi minus 16 pi. If you can't do that in your head, you can always work it off to the side. 6 minus 6 is 0. 3 minus 1 is 2. So this becomes 20 pi. Now at this point, we have to plug in 3.14 for pi. So this becomes 20 times 3.14. And I'm going to work that off to the side now. Again, this is 20 times 3.14. Again, we're multiplying a whole number, notably 20, by a decimal, notably 3.14. So we're going to take that decimal in 3.14 and shift it 2 times to the right, such that this becomes 314 times 20. And once we work that out, we'll take our 2 decimals that we shifted to the right here and shift them back into the left. All right, so let's work this out. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 4 times 2 is 8. 2 times 1 is 2. And 3 times 2 is 6. Let's add these together. 0 plus 0 is 0. 8 plus 0 is 8. 2 plus 0 is 2. 6 plus nothing is 6. Bring our 2 decimals back in. 1, 2. So we can see that 20 times 3.14 is 62.80. That's going to be inches squared. So this one is going to be B, 62.8 inches squared. All right, so number 14 says, if 4 factorial is the same as 4 times 3 times 2 times 1, simplify the expression. We have 9 factorial over 3 factorial times 6 factorial. All right, so our expression is 9 factorial over 3 factorial times 6 factorial. Well, let's go ahead and expand this. Again, if 4 factorial is the same as 4 times 3 times 2 times 1, then 9 factorial is the same as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Likewise, 3 factorial is going to be the same as 3 times 2 times 1. And 6 factorial is going to be the same as 6 times 5 times 4 times 3 times 2 times 1. Now, if you took the time to work all this out, the test would be up by the time you were done. So it should be obvious that in our numerator and denominator, we can cross out corresponding values, notably 6, 5, 4, 3, 2, and 1. So this simplifies to this. 9 times 8 times 7 over 3 times 2 times 1. And even this is a little difficult to work out because 9 times 8 times 7 will give you a big number. So let's see what we can do here. I can say 3 goes into 3 one time, and 3 goes into 9 3 times. Likewise, I can say 2 goes into 2 one time, and 2 goes into 8 4 times. So this becomes this. 3 times 4 times 7 over 1 times 1 times 1. All right. And this is actually very easy to work out. 1 times 1 times 1 is just 1. So this becomes 3 times 4 times 7 over 1. Anything divided by 1 is just going to be itself. So let's work this out. 3 times 4 is 12. And now we have 12 times 7. 2 times 7 is 14, carry a 1. 7 times 1 is 7, plus 1 is 8. So this is 84 over 1. Anything over 1 is just itself, so this is just 84. So the answer to this one is D, 84. All right, again, you have to be comfortable simplifying things to be successful on the ASVAB. And wherever possible, you have to use some mental math skills to work these out quickly. All right, so number 15 says find the distance between the points -5, -5, and -9, -2. So for this one, we have to know the distance formula, which is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And you might be asking yourself, what is x1, y1, x2, y2? Those are simply your coordinates. So again, in this problem, we have 2 points, notably -5, -5, and -9, -2. So we know this is x1, this is y1, and this is x2, y2. So let's go ahead and plug those in now. X2 is right here. It's -9, so this is -9 minus x1. x1 is -5, so this is minus -5 squared plus y2. What is y2? It's right here. It's -2 minus what is y1? It's right here. It's -5 squared. All right, let's work this out. This becomes -9. Negative is plus. So this is -9 plus 5 squared plus, again, this becomes -2. Negative is plus. -2 plus 5 squared. All right, let's keep working this out. -9 plus 5 is going to be -4 squared. And -2 plus 5 is going to be 3 squared. -4 squared, that's the same thing as -4 times -4. A negative times a negative is going to be positive. -4 times -4 is going to be positive 16. So this becomes 16 plus 3 squared, which is 9. 16 plus 9 is 25, and the square root of 25 we should know is 5. So the distance between these 2 points is C5. All right, so that's that one. You do have to know the distance formula for the ASVAB. It is on my reference sheet, so try to commit it to memory if you can. All right, so 16 says, what is the area of the shaded section of the figure below? Well, first things first, let's identify what shapes we're dealing with. We have a rectangle and a triangle. In order to find the area of the shaded section, should be pretty obvious that we're going to take the area of the rectangle, and we're going to subtract that by the area of the triangle. Well, how do you find the area of a rectangle? That's always length times width. And how do you find the area of a triangle? Again, that's 1/2 base times height. Well, let's start identifying those things and plugging them in accordingly. The length of this rectangle is right here. It's 12, so this becomes 12. And its width is right here. It's 4. 12 times 4 minus 1/2. What is the base of our triangle? It's right here. It's actually 9. We can see that. That is, in fact, the base of our triangle. Well, what is the height of this triangle? Well, the height of a triangle is always the distance from its highest point or its apex directly down. So here's its apex. Directly down would be right there. It should be obvious that the distance from here to here is the same as the width of our rectangle. So the height of our triangle in this case is going to be 4. All right, so let's go ahead and work this out. 12 times 4 is going to be 48. And let's make this math a little bit easier. Let's do 1/2 times 4. 1/2 times 4 is 2. So this is 2 times 9. 2 times 9 is 18. So this is 48 minus 18. And if you can't do that in your head, you can always work it off to the side. We have 48 minus 18. 8 minus 8 is 0. 4 minus 1 is 3. So the area of the shaded section is going to be 30 centimeters squared, which we should see is answer choice A in this case. All right, so that is it for this video. As always, I hope you found it helpful. In my opinion, you really need to memorize the formulas on my 13-page reference sheet to be successful on the ASVAB. Again, you could go to my website, asvabapp.com, and download it today. Nothing on my website costs any money. It's all free. And so I strongly encourage you to start memorizing those formulas. As usual, you're more than welcome to leave feedback in the comment section below. If you want to help my channel out, please consider subscribing to it. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.